In this lecture, we're going to be taking a look at expenditure multipliers. The syllabus includes talking about expenditure plans, aggregate expenditure, and the multiplier effect. Let's start off by talking about expenditure plans. For the purposes of the model that we're going to be talking about today, we're going to assume that on any given day, a firm's prices are fixed, and thus, for the economy as a whole, number one, the price level is fixed, and number two, aggregate demand equals real GDP. Just keep those assumptions in mind as we move forward. Aggregate planned expenditure is the sum of planned consumption, investment, government spending, and exports minus imports. And if you think about it, CIG X minus M is equal to real GDP. So when we talk about planned expenditure, because it's the expenditure method of calculating real GDP, we're going to say that this is aggregate planned expenditure. There's a two-way link between aggregate expenditure and real GDP. An increase in real GDP will increase aggregate expenditure, and an increase in aggregate expenditure will increase real GDP. So it works both ways. An increase in one will lead to the increase in the other. Influences on consumption include changes in disposable income, real interest rate, wealth, and expected income. If any of those increase or decrease, we can see a change in consumption. Disposable income is equal to aggregate income, or real GDP, minus taxes and plus transfer payments. So that's the amount of income that consumers actually have to themselves to spend on whatever they want. Consumption, expenditure, and saving. When we talk about this, we're going to say that planned consumption plus planned saving is equal to disposable income. We're assuming that people in the economy only do two things. They consume and they save. Whatever they don't consume, they save. And whatever they don't save, they're using to consume. They're buying stuff with it. And that's why we say that that's equal to disposable income. The consumption function is the relationship between consumption and disposable income, as you can see by the graph. The y-axis measures consumption, and the x-axis measures the disposable income. As we can see, as disposable income increases, consumption expenditure increases. Autonomous consumption is the amount of consumption that would take place in the short run even if people had no current income. Think about it. If you don't have a job, you still need to eat, you still need a place to stay, you still need to drink water, etc., etc. You still use electricity and whatnot. So you're still going to be spending a certain amount of money despite the fact that you don't technically have an income. And that's why we have something known as autonomous consumption. Induced consumption is the consumption induced by an increase in disposable income. We also have this thing known as the 45-degree line, and its height measures disposable income, and its width measures consumption expenditure. At each point on this 45-degree line, we say that consumption expenditure equals disposable income. Now keep in mind, this is not actually what consumption or consumers are doing. They're not actually spending all their disposable income. All this is trying to say is that this is the hypothetical where consumers do spend all their disposable income, and we're going to use this line to analyze the following. When we take a look at the consumption function and the 45-degree line together, we can see that if the consumption function lies above the 45-degree line, this means that expenditure exceeds disposable income. And if the consumption function is below the line, then it means that expenditure is less than disposable income and we're saving some money. We also have the savings function, and we have disposable income on the x-axis again, and saving on the y-axis. Points below the x-axis indicate that expenditure exceeds disposable income, and that there's dis-saving, or that people are dipping into their savings to finance their consumption. So savings is actually decreasing. Points above the x-axis indicate that expenditure is less than disposable income, and that there is saving. People have extra money that they're putting into their bank accounts. Marginal propensity to consume is the fraction of a change in the disposable income that is spent on consumption, and it's calculated as the slope of the consumption function. So we just take rise over run, or change in consumption divided by a change in disposable income. That'll give you the marginal propensity to consume. We also have marginal propensity to save, or MPS, and that is simply the fraction of a change in disposable income that is saved. Again, it's the slope of the saving function. It's calculated as rise over run, or change in saving divided by change in disposable income. Because it's a straight line, the slope is going to be the same regardless of where you take it on the function. Now we're going to put all this together. How does MPC relate to MPS? Marginal propensity to consume, marginal propensity to save. If we take a closed economy, in this case we're going to assume a closed economy, then as I mentioned before, we're going to assume that consumers either spend their income on consumer goods or they save it. So marginal propensity to consume plus marginal propensity to save is going to be equal to 1. And this is going to be important for a couple other equations that we're going to look at later on. If we have an open economy, that means that we're engaging in international trade, so some of our consumption is going to be on imports. So instead of simply saying that we're going to either consume domestic goods or save, we're going to also incorporate the fact that we're also buying imports, and that changes real GDP, so that's going to change our equation. So the new equation is as follows: marginal propensity to consume plus marginal propensity to save plus marginal propensity to import equals 1. And marginal propensity to import is simply calculated as a change in imports divided by a change in disposable income.